And we'll see that. So just before we go on to that, there's a few more features that I would like to explain on this drawing. First of all, in astronomy, longitude is equivalent to time. Why? Yeah. Let's say it's midnight in Greenwich. Okay? It's midnight in Greenwich. And then there's 360 degrees of longitude going all the way around the Earth, and coming back again. So that means every 30 degrees or every 15 degrees of longitude is equal to 1 hour of time. Okay? If it's midnight in Greenwich, then it's 11 o'clock here, it's 10 o'clock over here, 9 o'clock over here, and here is 1 o'clock in the morning, 2 o'clock in the morning, 3 o'clock in the morning, 4 o'clock in the morning. You see? The Earth turns toward the east. It turns from the west toward the east. That's why the sun rises in the east, because the Earth is turning in that direction, and it sets in the west, because then we're moving away from it in the evening. So at some point on the Earth, it's always midnight. At some point, it's always 1 o'clock, 2 o'clock, 3 o'clock, depending on the rotation of the Earth. Therefore, time and longitude are equivalent. Every 15 degrees of longitude is 1 hour of time, because 24 hours divided into 360 degrees gives you 15 degrees, right? So, we talked about how the astronomical coordinate system is a projection of the Earth's coordinate system into space. Now let's look at a picture of that. Here's the Earth, and here's the equator going around the middle of the Earth. Here's the North Pole, here's the South Pole. Now, when we project these things out into space, we have the North Celestial Pole, the South Celestial Pole, and the celestial equator. Is everybody clear on that? I want you to be very clear on this, because it's very important to any kind of measurements. Now we have, besides the celestial equator, we have something else called the ecliptic. Oh, what the heck is that? The ecliptic, as you can see, is a circle that's different from the celestial equator. That's because the axis of the Earth is inclined from its orbit by 23.5 degrees. So the plane of the Earth's orbit around the sun is 23.5 degrees different from the celestial equator. That's 23.5 degrees right there. Okay? So when we see the sun, the moon, the planets, they all follow the ecliptic, because that is the plane of the Earth's orbit, or the plane of the solar system. And that makes things a little complicated, because now we have the celestial equator being the projection of the Earth's equator, and the celestial poles as projections of the Earth's poles. But the actual movements of the planets occur along this line called the ecliptic. Okay? So we'll always see these two components of the position of any heavenly body: the right ascension and the declination or azimuth, which is nothing but longitude and latitude. Longitude is right ascension, and that's also time. Latitude is also declination or azimuth. Okay? Right, I'm going over this again and again because I want to make sure it's totally clear. Now, the Earth rotates around its axis once every day, and we arbitrarily divide a day into 24 hours. And actually, this is Vedic, because the day in Vedic conception is divided up into 24 horas. So we have this in Spanish also, hora. Hora means hour. So 24 hours, which are also called bhuktis in Sanskrit. When the Earth rotates around its axis one time, that means the sun is coming back into the same position over a particular place every 24 hours, approximately. It actually is a little bit different from that, and we'll get into that when we discuss sidereal time. There's all of these things have little exceptions. So then the Earth revolves around the sun in its orbit once every 365 days, 5 hours, 48 minutes, and 46 seconds. Just to make it interesting, it's not exactly 365 days. And we'll also show the reasons for that. This is called a tropical year. There's also a sidereal year, just like there's a tropical day and a sidereal day. And we'll show you the difference as soon as we build up enough background so you can understand it. Let's talk about the equinoxes. Here's a bigger picture in which the Earth is smaller at the center, okay? And here we see the north celestial pole and the south celestial pole. This is the north pole of the solar system, and this is the south pole of the solar system. So here's the celestial equator. And here's the ecliptic. 23.5 degrees apart at their widest. Okay? But you see there's a place where they cross. They cross here and here. This is called the vernal equinox, when the sun is on its way north. And then when the sun is on its way south and it crosses the celestial equator, this is called the autumnal equinox. And similarly, when the sun is at its most southward point, 23.5 degrees south of the celestial equator, this is called the winter solstice. And when it's 23.5 degrees north of the equator, it's called the summer solstice. So this is all because the axis of the Earth is inclined to the axis of the solar system by 23.5 degrees.
This is every year, right?
Every year, right. Right. In fact, we measure our year by the equinoxes, not exactly by the number of days. And the reason for that is the weather, the astrological patterns, the signs, the rashis, the nakshatras, all of this is determined with relation to the vernal equinox. The vernal equinox is a very important point. Actually, all the equinoxes and solstices are very important. So when the sun is in the north, it's summer in the northern hemisphere and winter in the southern hemisphere, like down in South America and Africa and Australia. When the sun is in the south, it's winter in the northern hemisphere, but it's summer in the southern hemisphere. So that's nice and confusing. Why is that? It's because When the sun is in the north, of course, it shines more in the northern hemisphere. The days are longer, they get more sunshine, the sun is higher in the sky, so they get more energy, more radiation. And similarly, when the sun is way south, in the northern countries, it's very cold because there's very little sunshine. The days are very short, they don't get much radiant heat, so that's winter. So the equinoxes and the solstices are the times of the year that mark the seasons. And of course, the seasons determine the weather. And if you're involved in agriculture, the weather is very important. So if you have a calendar that is based on the solstice, you can make very accurate predictions regarding the weather, because the weather has yearly patterns according to the solstices and the equinoxes.